In this episode, we are going to take a look on how to implement shaders from Shadertoy into our Panda3D application. So the two shaders what we are going to use from Shadertoy is first will be this one, this clouds shader, and I think this looks beautiful. I can watch this for minutes. So this will be the first shader what we are going to use from Shadertoy. And the second shader what we are going to implement in this video is this ocean shader. And this looks also very beautiful, and I cannot imagine how to do this kind of a shader, so that's why I'm just going to copy and paste and show you the process of how to use this shader inside Panda and GLSL. Okay, I'm just prepared here the code for this video, so we are just going to start with a blank canvas. So if I run now the program, we just have this plane with 4 vertices, and the whole plane is colored to white, pure white. And if I set the wireframe on, so on line 17, you will see that now we are just using 4 vertices, and of course this is 2 triangles. Okay, let's just uncomment this, or comment it out, I mean. Okay, so here we are going to load from the shaders folder the cloud-vert.glsl and the cloud-frag.glsl. Also here I'm loading the simple plane model or the plane geometry, reparenting this to the renderer, and also set it to use the shader, the my shader. We are going to later use the update method to actually update that movement of those clouds. In the vertex shader, I'm just specifying that I'm just going to use GLSL version 3.3.0, also adding the vertex inputs and the view projection matrix, and setting the GL position in the main function to model view projection matrix times the P3D vertex. So we are not going to use in this video the vertex shaders. The vertex shaders will just pass the vertices from the vertex to the fragment shader. And we are going to mainly work in the fragment shader in this one. So for now we are just setting here that the GLSL version 3.3.0, creating an output of type vector4 called outColor, and setting the pixel outColor to pure white, so 1, 1, 1 and 1, so red, green, blue and alpha. So the first shader what we are going to use, you will find it here on this link, so shadertoy.com, and I'm just going to add this link to the video description, you will find it. And this is this cloud shader from created by Nimitz, so from Nimitz. And here is the whole fragment shader code for this. And you will also find the shader inputs. If you click on this triangle, you will find that it needs some uniform inputs, like the eye resolution, which is the resolution of the window, the eye time, which is the frame time in our case. We don't need this eye time delta, and probably we only need these two, the eye resolution and the eye time, and probably the eye mouse, so the mouse position in the window or on the canvas. So just click here and also scroll down, and then shift click here to actually select the whole code, the fragment shader code, and press Ctrl+C to copy this, go back to Visual Studio Code, and for now I'm just going to delete all of this and paste the copied shader code from Shadertoy here. And we need to modify this code to actually make it work inside Panda3D. If you try to run it as it is, it will probably give us error, so it still shows the white plane, and here you will find that it misses some uniforms. Okay, it misses the eye resolution, the eye mouse, and the eye time. So we need to define these 4 or 3 uniforms. Okay, let's just start by defining these uniforms, and after this long comment, I'm going to leave it here. I'm just going to, on the line 24, I'm just going to copy and paste the 3 uniforms which are needed. So first is the uniform of type float, which will be the eye time or the application time or the frame time. The second will be a uniform of type vector2 called eye mouse, and this is the mouse position in the window, and the uniform of type vector2 eye resolution, which is the resolution of the window. And you can go back to Shadertoy and you will find it here. So the eye resolution is a vector3, eye resolution is a vector3 here. I don't know why it is a vector3. We just need a vector2 for this, so I'm just going to change it to vector2. And eye mouse is here, and it is a vector4. I don't understand why they are adding vector4 instead of vector2 for the mouse position. So it is a mouse pixel coordinates xy current blah blah blah, and eye resolution is the viewport resolution. So for mouse coordinates you don't need vector4, you need only vector2, and for the eye resolution you don't need vector3, you need just vector2s. And eye time is a float of uniform of type float. Okay, so let's try to run it again, and it will still not work. Of course, it still just shows the white plane, and here it says that no program is defined. And this is because if you scroll down, we don't have a main function. We have this main image, which works in Shadertoy, but it doesn't work in our case. So we have to rename this to void main and also just remove these arguments in this function. So to get rid of this no program defined error, I'm just going to rename this to void main. So every GLSL code, vertex shader or fragment shader or a tessellation shader or geometry shader needs a void main function. And this function doesn't take any arguments, so I'm just going to delete these two, the frag color and the frag coordinates. So delete these, and now of course we will have an error because the frag chord is not defined. The frag chord should be just the GL frag chord, which is on line 119. So I'm just going to copy the GL underscore frag chord and replace this this frag chord on line 118 with GL underscore frag chord. Okay, and next thing will be to actually scroll down, and we need this change this frag color to GL underscore frag color. So this is a built-in. Of course, this will still give some warning because GL frag color is deprecated after version 120, but let me try it. And now the next error, which says that shader input eye mouse is not present. So we have to add this uniform. We have to send a value to the eye time, the eye mouse, and the eye resolution in our Python script or in our Python file, so the Panda file. So for the eye resolution, I'm just going to set it to the Windows resolution. So self.plane.set shader input eye resolution. Remember that this has to be the same name as in the fragment shader, so eye resolution. And we are going to set to the eye resolution, which is a vector2, the Windows width and the Windows height. So self.win.get x size and self.win.get y size, so the width and the height. For the mouse, for the eye mouse, I'm just going to set it to a static value, So cell.plane.set shader input iMouse. So here we also named it iMouse. To cell.window.get x size divided by 2 and cell.window.get y size divided by 2. So this will move this point, this vector 2 in the middle of the window. So the window's width divided by 2 and the window's height divided by 2. And the last shader input which is needed is this time of type float. And this we are going to set in this update method. See, so this needs to be changed in every frame. So I'm just going to uncomment this line 35, and change the time to time, I and capital T, time. And also don't forget to add it to the task manager. So I'm just going to comment out or uncomment the line 31. And now we should be ready with these 3 uniforms. So we have the eye resolution, the iMouse, which are not changing, but the frame time or the eye time is constantly changing. So let me take a look if it works or not. And yes, it is working. Probably the only one thing is missing, but this is just a warning. The GLSL shader, blah blah blah, cloud frag does not contain a version line. This is just a warning, but I'm just going to add it. So we are going to use, of course, version 330. So on line 23, I'm just going to copy the hashtag version 330, which defines the GLSL version number. And now if I run it, of course, runs the game or the application runs, but we have this warning that GL frag color is deprecated after version 120. So we are just going to create one more variable, which will be an out of type vector 4, and I'm just going to call it out color. Okay, so out of type vector 4 out color, and I'm just going to copy this. And here in the main function, instead of setting the GL frag color, I'm just going to replace this with out color equals the vector 4 of color and 1.0. And now it should work without any errors and without any warnings. Just let me show you what happens if we don't send to this iTime the constantly changing time values. I'm just going to copy this line and set it here on line 30 to, let's say, I don't know, like 2. I mean, this is just a static or constant value, like 2. And I'm just going to comment out line 32, which calls the update method. And let me try it. So now we have just a static cloud. Although this looks also beautiful, but with the animation it looks much beautier or better. Okay, so I'm just going to undo what I did here. So it is oops, iTime. It is better like with the animation. And one more thing which I wanted to add. So if now I click on this icon to actually scale up the window, as you can see now we have these 2 rectangles, and somehow the whole scene is a little bit messed up. So this is because we still have to, if we resize the window, we still have to update this eye resolution uniform. So in this case we are going to add one more after that, or yes, after the task manager or before the task manager, I'm just going to accept an event, which is the aspect ratio changed event, and I'm just going to add a window resize method. So the window resize, I'm just going to define it here. So the window resize, when we resize the window, we're just going to always set a new shader input, or on the plane we are going to reset the eye resolution to the new window size. So self.window.get x size and self.window.get y size, so the width and the height. And also probably if we resize the window, we also should set the eye mouse uniform to the new width divided by 2 and the new height divided by 2. And now let me try to run and resize the window. So click here, and now as you can see it works without any problems, and I can just resize the window and no problem. So the second example, we are going to use this ocean shader, and I'm also going to add this link to the video description. So here is the fragment shader, and I'm just going to copy and so select all and Ctrl+C to copy it. Go back to Visual Studio Code, and I already prepared the Python file, so ocean.py, the vertex shader file, and the fragment shader file. So in the fragment shader, I'm just going to paste the copied code, and we are going to modify it to work, to make it work inside Panda. So if we go back to Shadertoy and click on this icon or this triangle, you can see that we need almost the same, not almost, but the same uniforms: the eye resolution, the eye time, and probably the eye mouse. Yes, we can move this with the mouse if you press and hold. And of course we are going to use, instead of vector 3, we are going to use vector 2 for the eye resolution, vector 2 for the eye mouse, and a float for the eye time. So let's go back to Visual Studio Code, and I'm just going to add first the version specification. So this will be on the first line, I mean after this comment. So we are going to use version 330, and of course, as I said, we need the 3 uniforms: the eye time, which is a type of float, the eye mouse, which is a type of vector 2, and eye resolution, which is a type of vector 2 also. And here, as you can see, the eye resolution is already used on line 17. And one more, what we are going to need is the output color. So out of type vector 4 and out color. So we added these 5 lines. And of course, if I run it, it will still give us an error, ocean.py, and as you can see, no program is defined. So we still need to rename the where it is, get pixel, this main image to main. So let's do this. So rename it to main, just delete the image part, and also just delete these arguments, function arguments. We don't need this. So void main, and of course we should also rename the frac chord to gl_frac chord. So gl_ and with the capital F, so gl frac chord. And of course here the frac color should be out color. Color equals to a vector 4 of these. And now I think it should work. And of course we have still one error, which says that implicit cast from vector 4 to vector 2. And here it also says that the problem is on the line 202. So here on line 202, vector 2 UV, we are creating this, or we are adding to this GL frac a vector 2 of ij divided by 3. But this GL frac is a vector 4, so we have to just swizzle it. So GL frac dot x and y plus the vector 2 of ij, and now it should work. Yes, it is working. So we cannot add a vector 4 to a vector 2. We have to do swizzling, so vector 4 dot xy plus the vector 2. And let me just show you the ocean.py. So here I already added the shader inputs, the eye resolution, which is the window's width and the window's height, and also the eye mouse, which is the window's width divided by 2 and the window's height divided by 2. And also added to the task manager this update method. So here we are setting the eye time uniform to the frame time. And of course, when the aspect ratio is changed, so when we resize the window, we call the self.win_resize. And in this case, in the win_resize method, we just setting the new window's width and the window's height to the eye resolution uniform. And also to the eye mouse, we are sending the window's width divided by 2 and the window's height divided by 2. So when we run, and if I resize the window, it works perfectly. Okay, so as usual, this code will be uploaded to GitHub, and the link will be in the video description. So thanks for watching and have a nice day.